So what is this about, actually? So recently I had the pleasure of working on one of our KTX libraries that we just released at Android Dev Summit. If you know the Play core library, which is used for two things mostly. For in-app updates, so if you want to initiate an update in your app from within your app, or for downloading dynamic feature modules from Play, you would use the Play core library. However, we're not going to talk about these two APIs here. It's mostly the lessons I learned and a few interesting tidbits about making Kotlin extension libraries for an existing API that I want to talk about today. And that will include coroutines and flow later in this presentation. So what is KTX, actually? So you've seen Alec included one of the KTX artifacts for lifecycles in his application to convert flow to live data, and you've seen this -KTX postfix on a suffix on the artifact name. Well, KTX, it's just a name that we came up with when we announced we were going to support Kotlin on Android, and obviously all of the Android APIs are made in Java. So to make them a little bit more Kotlin friendly, we started releasing these Kotlin extensions. So the name comes from Android Kotlin Extensions. We usually call them Android KTX. Most of them are in the Android X library, but not all of them. And yeah, it's just a name. It's not a Kotlin language feature. There's no such thing as KTX in Kotlin. Now there's KTS, which is Kotlin script that can be used for your build Gradle files, but that's completely unrelated. So it's not a language feature. It's just a name that we use in Android. But it does use Kotlin features, and these are just normal language features that probably make Kotlin the language that we like, right? So we like Kotlin for many things, some of them being the ability to define extension functions, extension properties. You can build like DSL builders for type-safe kind of building of your objects. We can do operator overloading. We can use named and default arguments. Most of these things not possible in the Java programming language syntax, but we can do them in Kotlin. And they just make our APIs a lot nicer to work with, right? If you can have even something like named arguments, and it's just way nicer to work with an API where you can literally see what kinds of arguments you're passing and what they do. So we use all of these to create extension libraries to augment, to improve existing Java APIs. They don't give you something you cannot do in Java. They just take an existing API, add some extensions on top of it to make it nicer to consume from the Kotlin side. Now, the main thing we use, of course, is extension functions, because they make it so easy to tack something on to an existing API, to an existing class. And even though they seem like magic, like how does the compiler do it? How does it put things in a class that exists in a jar, and like how do we access it? Well, the answer is it doesn't. It doesn't actually put anything inside an existing class. Extension functions, the thing you write at the top in your Kotlin source file, what this gets compiled down to is simply a static function in a completely unrelated class. So if you have a file, of course, like file.kt, that creates an actual JVM class called file.kt that contains your extension function. Even though the extension function is defined on a base type, on an activity, on whatever you want, the actual function that exists in the JVM library that's compiled from that is a static function on the file.kt class. And what it takes as a first argument, even though you didn't specify it in the arguments here, I should use the clicker, even though you only specified one argument, there we go, it actually creates two. So it takes the base type, puts it as the first argument, and then the arguments that you specified. So this all is done by the compiler. And it has some very interesting implications that I will show you in a sec. And just very quickly, extension properties. Now, we know properties and functions, like talking about regular properties and regular functions, are different, right? One will create a backing field. So if you define a property on a Kotlin class, it will define a backing field in your JVM class that can hold some data. Now, when we talk about extensions, an extension property is no different than an extension function, meaning it exists entirely outside of a class. It can't put a field in a class that already exists. So your properties, whatever I say from now on about extensions, will be both about properties and functions because they're the same. An extension property will actually create a function. And again, the base type will be put as the first argument to your function. Sorry, this archetype is not needed here. I made a mistake. So this base type will be put here. Whatever you define as a getter will just be the body of the function and will return it. Now, the interesting thing here is you have to have a getter for a value. You can't just have a result because, again, there is no backing field. So there is no place to store this data. That's why it will be a function that will be generated here. And we will look at the actual bytecode that might make it easier to understand. And so I said the fact that this is done by the compiler, that these are static functions that exist outside of the class that you define it on, actually has interesting implications or caveats. Like I just said, you can't have backing fields for properties. One interesting thing that happens that we will look at is static dispatch. And it also generates some additional metadata that I haven't shown in the previous slides. So let me talk about these three, and let's look at an example. Now, the example code is actually pretty rubbish. It's not code. Anything I show today is not code that you will want to put in your actual application. It's just stuff I came up with just to show the bytecode. It doesn't mean that I would define these extension properties on my activity. So here I defined some extensions on my activity. So let's say I want to know if the activities I'm using support fragments or not. So the fragment from, the base activity from the framework cannot use Android X fragments because it doesn't know anything about it, so I will return false. Now the fragment activity that comes from the Android X library, I want it to return true, right? Like I said, this isn't something that it makes sense. It's just extension functions that I've defined on two different classes, right? And what I'm going to do here in my activity, which is a fragment activity, actually, if you go up the class hierarchy, is I will call these extension functions. So here, I'm calling the one on fragment activity. But here, I'm casting my fragment activity as an activity and calling this function. So you already see that if I control-clicked, it went to this class, right? So to this extension function. Now, this will be a little bit complicated, but bear with me. I've also created two additional util classes to show you. So this will be a demonstration of static dispatch of the thing that I'm trying to explain. And to contrast it, I also created two classes to show you dynamic dispatch or virtual dispatch so that you can see the difference. So here I created two classes. Activity util that will do a similar thing that my first extension. So can I use fragments? False. OK. And now I have a specialized version of this class, which I will use for my fragment activities. And this one overrides the method, can I use fragments? True. OK? Everything understandable so far? OK. So I'm going to do a similar thing. Just like here, as I'm calling my can I use fragments on my fragment activity, I will create a fragment activity util and call this. And now I'm doing the same thing as in the second line here. So I'm taking my fragment activity util, casting it as activity util, and calling can I use fragments. So what do you think will happen if I control-click on this to go to the source? Which version will show?
We'll both move to the same exact function.
Which is? Which one?
If you false.
Yep, it goes to false, and this one goes to false. Sorry, this one goes to true. Yes, because I didn't cast.
But
okay.
They both show true.
Okay, let's try. Sorry, I will not run it because I don't have printlns here, but let's do that. What do you think will be printed in each of these?
There was two lines true, probably.
So can you show us again this which declaration of you can use fragments for fragment activities in the
Yep.
or the other?
Which one? Sorry. So remember, for regular activity, it's false. For fragment activity, it's true. And let's see what's going on here. And then we'll look at the bytecode. And let's see if I can run this. And sorry about that. Application, run, let's see what happens. Just give it a moment. Yeah, here we go. Okay, so we have true, false, but then true, true. So different things happen, right? Depending on if I used extension functions or if I used regular class inheritance. Why is that? Let's look at the bytecode. So if I go show Kotlin bytecode, and let me actually delete these print statements. It'll make it a little bit clearer now. OK. If I look at the first one, you can see this invoke static. That means, damn it. There we go. That means it's invoking a static method, because like I told you, extension functions get compiled to static methods on a completely unrelated class that's unrelated to your actual class that the extension is on. And it's invoking it. It's deciding which one to invoke, based on compile time checks. So if we...
It's not accurate.
Sorry?
It's calling activity utils.
Yeah, activity utils can use fragments with fragment activity, right? Because here I'm calling it on the fragment activity, so it knows which one to call. Here, because I cast it to an activity, at compile time, it calls the activity version. So at compile time, it has to decide which extension function to call. It's not using inheritance. It's simply looking at what I passed as the argument, or in this case, what was the receiver. So here the receiver is my fragment class. Here it's my activity class. And it decides which function to use. Whereas in this case, it's using regular inheritance. So it's deciding at runtime. So at runtime, even though I'm casting this to activity util, it still is a fragment activity util object. And it knows that. So it's going to call, actually, this method. That's why they both return true. Anyway, this is a little bit complicated. I would ask everyone to, if you want to explore it further, use the Kotlin bytecode decompiler. That's one of the tools that you can use to examine what's going on in the bytecode, what Kotlin actually compiles down to, and look at it yourself. And the main difference here is, if you look at it again, these are invoke virtual calls, right? So these are dynamically dispatched at runtime according to the class that the method is on, as opposed to the static methods. OK, but let's move on. Next thing I wanted to show you. Right, so extension functions. So as I told you, they get compiled down to regular functions that take your receiver as the first argument. So how does the IDE, how does the compiler know that they actually are extension functions? Now, if I created a Java file here, new Java class test, no. I can actually try to access these, right? So I can take my activity utils KT file where I define them, and I can see all these methods that I find. So can I use fragments, taking activity or fragment activity as the first parameter? So in Java world, in the JVM world, they're just regular static methods. There's nothing to say that they're extension functions. So how come in Kotlin, if I try the same thing, activity util, I don't even see the KT version. It's simply not here. Like the compiler, the IDE will not let me call them as regular functions. The difference is in the metadata that the compiler creates. So if I go into activity utils, still with my Kotlin bytecode decompiler here, and scroll to the very bottom, you can see this file. So this is a file that's generated together with this file. And it's put in your meta-inf directory in your jar files that contains some metadata about this Kotlin module. Moreover, the class that is generated and the extension methods that are generated from this contain an annotation, Kotlin metadata, with additional file that it's not human readable, but it's readable both by the compiler, and it's used by reflection at runtime if you do use it. And it contains the information that is needed for the compiler to extrapolate the information that these are extension functions, and that's how they should be used. Now, this all happens for you automatically, so you don't have to care about it, unless you're trying to release a library that is a Kotlin Extensions library, and you're doing any kind of weird post-processing of your code. And that's what I had to do for the PlayCore KTX library. And suddenly I found that all my extension functions were simply not visible from Kotlin. Let me actually show you what happens. So if I build my library, go into the AAR, open it. Let's do it. Show in files. Let's go do some surgery here on the class file, on the classes jar. So here's the Kotlin metadata file. I will just delete it from within classes jar. OK, close it, update the file. OK, so now I have my library built, my KTX extensions library, but I deleted the Kotlin metadata. So now one thing that remains is, let me switch to using the jar directly instead of the project. So here I'm using the jar that I just modified. And let me sync the project and see what happens. I hope I did it right. Syncing. OK, now everything here is red, right? It doesn't find this. There is no extension function on my activity. Even though the function still exists, I can see it from Java, because now it's just a regular JVM function. The Kotlin compiler doesn't know how to even connect it with my activity. So remember, don't delete these files if you're distributing a Kotlin library. Now, you can find many advice on Stack Overflow saying, oh, these Kotlin module files, they're not needed. And mostly that's true. If you release an application, if you're not reflecting at runtime, you probably don't need them in the APK. But if you're releasing a library, an AAR or a jar that other people will compile against, these files need to be there, or they will not be able to use your extension functions. OK, so let me just tidy up here, because we'll be using these files later. Let's actually delete this. And let me just go back quickly to using the project instead of the jar file that I modified. OK, let it sync in the background. So yeah, this was demo time. We didn't discuss this one. This one's pretty easy. Because we're only generating functions, we're not actually manipulating any bytecode in existing classes. We can't have backing fields. We can only get computed values for extension properties. Static dispatch, so the choice of which version of the extension functions to call is made at compile time, not at runtime. So it's different than with regular inheritance. And Kotlin metadata and Kotlin module files. If you're distributing a library, these are needed. Please don't delete them. If you do any post-processing of your Java classes and you, for example, change their names, they will no longer match the metadata, and again, things will break. So make sure you are aware of that. More caveats that I found. Now, the library that I was working on, PlayCore, was not made with Kotlin in mind, let's say. So the developers working on it were Java developers. They didn't think, about the things that Kotlin developers think about. And for example, they named their getters like this. They were functions, so status, with no arguments. And we all know probably that in Kotlin, in order to have this nice property syntax, your getters and setters have to be get status, set status, right? So it looked kind of ugly, and I really wanted to have this property syntax in Kotlin. And so in my extension library in PlayCore KTX, I added it, but I realized there's no way for me to get rid of the original name. If anyone knows how to do it, I would really like to know. But as far as I know, there's no way to do it. So I had the choice, do I not add these and just leave it as is? Or do I edit? And then if someone tries auto-completing in the IDE, they will see both names. I decided to add them. So it'll be ugly if you do autocomplete. But then if you look at your code, you will have these nice properties. So it's a trade-off. To avoid issues like this when writing Java libraries, if you want to make them Kotlin friendly, there's a lint check in Android Studio that is disabled by default. So if you want to do it, if you're writing a library, go in the inspections panel, enable this interoperability in Android for Kotlin, and it will check these things for you. Like, are you naming your getters and setters properly so that Kotlin will be able to use them as properties? Are you using lambdas as the last parameter so you can use the nice lambda syntax, shorthand syntax? Are you not using Kotlin keywords like is, for example? Like, I think Espresso or other testing libraries were using is as their method names, so you had to put them in backticks in Kotlin. And of course, nullness. So this is very helpful. If the original developers used this for the library, I wouldn't have this problem. And the last thing I learned, and again, if anyone knows how to do this, I would really like to know. As far as I know, there is no way to attach Java docs or whatever kdocs, reference docs for your Kotlin library to the IDE. So when you do this quick help, I want to get the description of my method, of my property. There's no way to do it if your library is not open source. And the reason being, for Kotlin libraries, Android Studio and IntelliJ will only pull the Java docs from a sources artifact. So normally when you distribute your library, you can have 3 artifacts. The actual jar with your code that will be used for compilation, a -javadoc jar, and a -sources jar. Now, the Javadoc will contain HTML files with all your Java docs, and that will work for Java, but it will not work for Kotlin. And the only way to do it for Kotlin is release the actual sources. Now, unfortunately, the PlayCore library is not open source. So I had to leave it like this. I'm still working on finding the right tools that will let me process the sources to rip out all the function bodies and just leave the Java docs. That would be one way of doing it. Unfortunately, currently, I found that Docker and MetaLava, the 2 tools that I know, don't support that. So we'll have to wait. OK, now moving on to the second part of my presentation. How are we on time? I think we're still good. Now, all of this, what I just showed you right now, all this was just about having nice syntax, right? So it was about maybe changing the names a little, having nice properties or extension methods. It didn't introduce any actual new functionality. However, as we heard from the previous presentation, the power of Kotlin is somewhere else, right? It's coroutines, it's flows, it's it's giving you new language features combined with a coroutines library that let you do async calls in a really, really nice way. And in fact, in Android and Android X, Jetpack, we really like coroutines, and we like creating APIs that start making use of these Kotlin features to make your lives better. However, I'm going to show you today that all of you can actually start converting your existing async APIs into something that's better to work with from Kotlin. OK, so what is actually wrong with a typical async API? And there are a lot of them in Android, of course, because there's a UI that you can't block it with any I/O or anything really. It has to be super fast. So anything that is taking longer than X milliseconds has to go to a different thread, do its job asynchronously, and then usually signal back to the UI thread so it can continue so it can update itself and continue running. Now the problem is, all of these callback or listener-based APIs, they require a lot of boilerplate. So you need to register a listener or a callback at the right moment. Then, of course, remember to clean it up, to not leave any, to not have any leaks, to not also have any, I would say, CPU leaks, as in work being done still in the background while your activity no longer is expecting it to happen. And of course, because you need a lot of boilerplate, it's also super easy to misuse. So like I said, you get possible leaks. And then you get into callback hell. So maybe having one callback is not the worst, but if then after loading your data, you want to process it, and then you want to, save it, send it somewhere, and finally show it in the UI, then you get all these chaining requests, and it just becomes hell. Of course, there are solutions like we discussed, like RxJava and Flow, And that's, I guess, the direction where we want to go with these APIs. And I'm going to show you that there are actually already building blocks inside coroutines that let you easily convert one to the other. So let's start with making one distinction. So coroutines, as it was originally made, didn't support something like RxJava, right? It didn't support streams of data. It was made for one-shot requests. So you have a function, it returns the result, and that's it. It can be suspending, so that means it will not block your thread. It can do its thing on a different dispatcher. It can come back to your main dispatcher and give you one result. And that's useful for, like I said, one-shot requests. Like, let's talk about the fused location provider in Android, which gives you locations from the GPS. If you just want to know, hey, what's the last known cached location that you have, you would call something like last known location, gives you one location, that's it. However, for streaming requests, so something like request location updates, where you continuously want to be updated on where the user is when they're moving, based on different criteria, this requires emitting many events, right? And so here we start talking about streams, about something like Rx data, and here we're going to try to implement this in Flow, which now you are familiar with thanks to Alex's presentation. Okay, so what are the building blocks for converting existing APIs to coroutines? Let's start with one-shot requests. Now this is a function that hopefully you will actually never have to use. Because hopefully in the future, all of your APIs will be suspending functions and you will not have to do it yourself. But if you want to use it, you'll find it in the coroutines library, so suspend cancelable coroutine. It takes a block that you will be using to initialize, to start loading your data, to start doing your operation, whatever you need. And we will use two APIs on it. So it gets a continuation. And we will use two methods on it, resume and resume with exception. So what this actually does is it executes your block synchronously. So as soon as you call this, your block gets executed, and then it suspends the function. And when you complete your work, at some point from some thread, you will call resume so that your suspending function can resume working, hopefully with a result. And I'll show this when coding in a second. OK, we're still good on time. Now for flows, similarly, we have these low-level building blocks that, again, hopefully you will not actually need to use them. So for example, in Alex's presentations, we've heard about retrofit, right? And there was a question, so what's does it make sense to actually convert a list to a flow because it's a suspending function? Well, yes, retrofit will support returning flows, but until then, you have to, until these APIs like retrofit, like databases and so on, until they give you flow out of the box, you will be using these builders and some other functions as kind of adapters to bridge the old world with the new coroutine flow world. OK, so we will use callback flow, which, as the name suggests, is made for converting callback-based APIs into flows. And like I said before, to decide which one you want to use, suspend cancelable coroutine or callback flow, this is for one-shot requests, one result only. This will be for emitting multiple events in the course of time. So this one takes a block as well, which will be executed synchronously as well, like suspendable suspendable cancelable coroutine. And it gives you a producer scope inside, which you can use to emit results, emit events. At some point, you will have to close it, hopefully without an exception. And at the end of this function, you also call await close, which I will show you in a second. OK, demo time. And let's hope this works. OK, so.
Excuse me.
Yep.
Chances to switch to the Dracula color scheme?
How do I do that?
Preferences and the first option at the top. I don't know the script.
You mean settings? This is Linux.
Yeah, I think so.
Appearance.
Yeah.
No. OK. Let's have it your way. But now I don't know how to code. OK, so here we have this app that, let's see if I got the code cleaned up correctly from last time. Yeah, so all it does is it has one text view that will be showing the user's location, OK? For now, it's unable to get it. That's fine. It's all in one file. So of course, normally we wouldn't do it in an activity. But for brevity, it's just one file. Just don't do it in your own apps. But it'll be easier like this for me. And currently what it does, it uses the fused location provider from Google Play Services to get locations. So here we have the fused location client. We initialize it in onCreate. And this API is inherently callback based. So because it's in Google Play Services, it's a separate service. It has to go through remote function calls from our app to Google Play Services. So everything we call on it is asynchronous. It's based on callbacks. So even things like getting the last no location. So in onStart, when I start the app, I want to first get the last known location. This is one result. And then I will be listening for any location updates that happen. So starting with get last known location, it's here, fused location client. Please give me my last location. But it's not that easy because callbacks, because it's asynchronous. So we added success listener. In it, we will get the last location, and then we can show it in the UI. In the case of failure, it's another callback. We are unable to get the location. And we print a stack trace. OK. And of course, it doesn't sound so complicated. But like I mentioned, it gets complicated once I want to process it further, right? If I have another API, maybe I want to update the location to my server. Here, I would have nested callbacks. So again, upload location on success something, on failure something. It will be hell. But we'll not be doing this. So I'm going to delete it. I just want to show you that we don't want callbacks because it just gets terrible and once you start adding more. OK, so let's use suspend cancelable coroutine to turn this into a coroutine call. OK, so I'm going to go to my location utils file, which is in my KTX library. And let's try doing something like, so it'll be a suspending function, request last location. This will be on the fused location provider client. And what we want to do here is directly return the result of suspend cancelable coroutine. That's the thing that I showed you, right? And we wanted to return a location. Now it'll be nicer like this. And here in this block, we get a continuation, right? So let's rename this. We get a continuation. So like I said, after this block executes, the function will suspend itself. And at some point, we need to call the continuation with a result. So because we're in a fused location provider client, we can call the last location. And of course, we want to set the listener just like we did in our regular app. So add on a success listener. And when we get the location here, what we call is continuation. Resume with the result, with the location. And that's it. That's how I just converted a callback-based API into a coroutine. Let's try running it. Run. Let's see what happens.
You're not using it yet.
Yeah, sorry. I went too fast. OK. So here, yeah, get last known location. Now, as we've seen in Alex's presentation, we need to have a scope. So I actually have one of the KTX libraries that I mentioned. So I get a scope for free here from KTX. I want to launch when started. It's one of the helpers here. And I want to do, where's my client? Fused location client dot request last location. So that's the extension function that I define. OK, and this isn't going to work. because it's still unable to get location. Moreover, nothing happened. There was no exception, nothing. And that's because I forgot one very important element, which is, let me go back here. What happens on failure, right? So if I do failure listener, there's another thing that I always need to remember: handle all states, otherwise my coroutine will never actually resume. So let's resume with an exception, and let's see if I actually got one. What if I run it now? Running. Or did it run already? There we go. See, I was getting an exception from my Fuse location client, so never forget to handle all states here. Now, if I go back to my main activity, now I could, of course, wrap it in a try-catch. I know what the exception was. I didn't ask for permissions to get location, so I'm going to uncomment that, see if that fixes it. So now it asks me, yes, allow, yeah. Let's try running it again. And now I can get location. OK, so that fixed it. So always remember about exceptions. I should really have a try-catch here, inside the scope. As far as I know, there's no way to do it, as Alex showed you, with operators, because we're not in the flow world here yet. So this is a regular coroutine. I could just print it here. Always remember to, first of all, handle them and then check them outside. OK, so this is suspend cancelable coroutine. It's actually pretty easy. You just remember to handle all results, either resume successfully or resume with an exception. OK, let's move on to updating the location continuously as they come in. So here it works like this: request location updates. You give it a location callback, which extends the location callback class. It'll get called many times in here, and we'll be showing that location. So this is a bit complicated in the regular case. So right now, I have to track if I'm actually listening to updates. I have to have this location callback defined myself. On start, I have to start updating location. And then in my on stop, if I'm listening to updates, I have to stop updating location. Now, as Alex explained, with scopes, with coroutines, with flow, we want to get rid of all of that. I just want to get a flow and collect it. So before we actually start implementing it, let me delete this. Let me delete stop updating location. I don't want to care about unregistering a listener. I don't want to care about if I'm listening to updates or not. And I don't want to even have this location callback here. I don't want to implement all these things. I just want a flow. OK, so now we need to move this, right? So let's start another function in our location utils. So this will be a function, again, on the Fuse location provider client. And it will be, let's say, request updates flow. And we will use callback flow as the builder that will help us create it. Now, of course, we will need the callback. But from now on, it'll be an implementation detail of my flow. If someone uses my API, they will never have to deal with it. So let's create a location callback and override on location result. OK. And since here we have this producer scope in the callback flow that we'll be using to emit items, I can actually offer the result here. But this is a location result, so just need to do deal with nulls. If this is null, I want to return. But if it's not null, I will actually, there are many locations in there. So result, locations, offer location. OK, so now we have our callback that will be emitting or offering results as they come in into the producer. So that will be emitted by the flow. But this is just a callback. Now we actually need to start requesting updates. So request location updates, this version. Now this is just a convenience function I already have defined for creating the correct object that the API expects. I'm going to pass my callback here. I'm going to do it on the main looper, just because this API needs it. Now this in itself, just requesting updates, is already an asynchronous API. Now I could use a success listener here, but I don't actually need it. If this is successful, if I successfully submitted my request for updates, at some point I will start getting them. So I don't actually care about success here. It will just start working. However, I do need my failure listener. So if for some reason my app was not able to connect to Google Play Services, this failed, this flow will never work, I will close my flow with the exception. So whoever is trying to listen to my flow, they will actually get the exception they got from the library itself. It will be bubbled up to the flow. And the last thing you always want to call in callback flow is await close. And await close means this flow will continue working until someone closes it, either from within, so if I close it with an exception, for example, or if someone stops listening it from the outside and cancels the scope, that also means this flow will be closed. And here, what's interesting, you can do cleanup inside this function. So I'm passing a lambda here. Let me scroll down, where I can do cleanup whenever this flow is closed successfully or with an exception. And what I'll do here is I will, what's the command for unregistering? Stop. So request location updates. And then what's the one? Remove location updates. OK, so I will remove location updates with my callback. So now, regardless if this flow ends with an exception, if someone stops listening to it, if the scope is canceled, it will always clean up after itself, and it will remove our callback from the API. So now let's try using it from here. So again, because we'll be collecting it, I need to call it in the scope. Launch when started. So let's get our fused location client. Request updates flow. Collect. And we want to update our UI. So I didn't even do it here. Show location. So this is for the coroutine version, and this is for the flow version. Yep. And let's see if it works. Did I forget anything? I forgot to handle exceptions, but it'll do for now if it works. OK, so we're launching it. It got the last known location, so that worked fine. Now, I don't know if you've seen, but the emulator now has this fancy Google Maps UI, so you can just click around. That was missing for a long time. And so I'm going to set the location and see if it changes. Give it a sec. Yep, it changed. So I can do it again and again. And as long as my coroutine scope is running, it changed again. As long as I'm in this activity, this flow will keep being collected. And now if I just back out of it, the scope is canceled, the channel is closed, and the coroutine that was launched to collect my flow is also done. No leaks, callback was unregistered, everything is working fine. OK, and I'm almost done if anyone's worried about time. So yeah, just remember a few things. Always handle failures, both inside and outside of the flow or coroutine that you're creating. Remember to release resources on completion or cancellation. There's this await close that you can use in the flow builder. When you're using suspend cancelable coroutine, it also has methods for doing that. It has invoke on complete. Invoke on cancelled. So there are ways of always cleaning up after your coroutines. One idea for so my flow was pretty easy. It always emitted locations, nothing else. But if you have heterogeneous result types, you can use sealed classes. Like for example, in my PlayCore KTX library, if you're listening for update results for your app, it will emit one of these update results, which is a sealed class, and it's always one of these 4 types. So that whoever is collecting your flow and looking at the events that are coming in, they can just use an exhaustive when and just check what kind of update was emitted from this flow and handle it appropriately. For naming, you can try using the same names for your coroutine functions as the regular API names. I couldn't do that because of how the original API was structured. However, if you have an API, an async API, that in the regular version takes 1 argument or 2 arguments as callbacks, you can simply reuse that function name and just make it a suspend function, returning the result directly, or throwing an exception in the case of failure. I couldn't do that because my functions on the location API did not take arguments, so I couldn't reuse the same name for the suspending function. When to use, like I said, ideally, you as app developers will never have to use suspend cancelable coroutine and callback flow. However, as it is right now, we will still be using many Java-based APIs, many APIs that are not yet coroutine enabled. And to build these converters from callback APIs to coroutine APIs, you can use them, you can build those once, and then your app teams or other people will be able to use them. So they're helpful until the actual databases, networking, and whatever you have will expose APIs that are already coroutines. And OK, ending now. We already have a lot of these in Android Jetpack, so check out like Room and all the lifecycle extensions that we have, the coroutine scopes that we offer you. There's a lot of libraries out there from Google that already use all of this. So thank you. If you have any questions, I'll be around.